We now move on to sequences and series. And this is kind of like the last big topic of Calculus 2. And first we're going to start with sequences. So first off, what is a sequence? A sequence is really just a list of numbers. So whenever you see sequence, what you want to think is this is just a list. Now we're going to have series later, and that's different. But right now we're just going to have sequence, and that's just a list. Now a sequence, what it does is it takes an integer, the positive integers really, so integers that are greater than 0, and maps them. So integers greater than 0, those are your numbers 1, 2, 3, 4, ... So we're going to be taking those numbers, and then the sequence is going to tell us what to do with those numbers. So for example, let's start with 1 over n squared. And we use these curly brackets to denote that this is a sequence. So what this sequence means is it's a list of numbers. We start with n equals 1. And I'm going to write the n equals 1 above it. You don't really write this, but just so we know. So when n equals 1, I have 1 over 1 squared, which is 1. The next number in this sequence is going to be n equals 2. So if I plug in n equals 2, I get 1/4. Then I plug in n equals 3, and I get 1/9, and I keep going. So there's your sequence of numbers. It's 1, 1/4, 1/9, 1/16. I could do something like the sequence 3 over n plus 3. So now I start again with n equals 1. So when n equals 1, looks like 3/4. So 3 over 1 plus 3. Next would be n equals 2. So it looks like 3/5. Then 3/6, which is 1/2. Then 3/7, and ... It would keep going on forever. We could do a tougher one. Let's say that my sequence is given by -1 to the n times 2 to the n. So what sequence of numbers is this? So when n equals 1, I'll have -1 to the 1, which is -1, times 2. So it looks like -2. When n equals 2, I'll have -1 squared, which makes it positive, and then 2 squared, which will give me a +4. Then it looks like a -8, +16, and it keeps on going forever. This is called an alternating sequence. We'll get more to that later, but this is an alternating sequence. What about the sequence just 5? So when n is equal to 1, I plug it in and just get 5. When n is equal to 2, plug it in and get 5. When n is equal to 3, I just get 5. So this is just a constant sequence, and it's just 5s all the way around. Now, a big topic of sequences is, do they converge or do they diverge? And that's what we're going to get to. So the last example that I did was the sequence 5. And we said this was 5, 5, 5 forever. The limit of a sequence is where you take the limit as n goes to infinity of your sequence, and we'll call it an. So as n gets bigger and bigger, what happens to this sequence? So let me go back to this example. What's the limit as n approaches infinity of this constant 5? Well, that's just 5. The limit of a constant is a constant. So what we say is that the constant sequence 5 converges to 5. So we're really interested to know if a sequence converges, and if it does converge, what does it converge to? So let me give you an example of a sequence that does not converge. So let's look at n squared minus 2 over n. So we'll call this one example 1, we'll call this one example 2. Does this converge? And if it does converge, what does it converge to? So we're going to do the limit as n approaches infinity of n squared minus 2 over n. And remember, you might have forgotten from Calc 1, but when you're looking at limits towards infinity, you really only have to look at the highest power terms. So my highest power terms are n squared and n, the top and the bottom. And I'll have an n that cancels, so I'm just left with n. So the limit of n as n approaches infinity is infinity, which is not a number. So what we say is that the sequence n squared minus 2 over n diverges. Now you might have forgotten the rules here, and that's okay. The rules, there were really 3 of them, but we're only going to look at the positive infinity. So if I have the limit as n approaches infinity of 1 over n to some power, that's going to be 0. If I'm looking at the limit as n approaches infinity, where the power is on the top, that's infinity. The limit as n approaches infinity of a constant is just that constant. So you might have forgotten that, and that's okay. I'm just going to remind you of those now. Just keep in mind, we're looking for, does this sequence converge? Does it diverge? And we're going to use those types of rules. It is possible that you're not going to get 0 or infinity, and I do want to give you an example of that. Let's say that my sequence is given by cosine of n. So I don't know if you remember what cosine does, but cosine, the graph of it, kind of looks like this. It goes up and down, bounces back and forth. So the limit as n approaches infinity of cosine of n, that actually doesn't have a limit because it just bounces back and forth. It doesn't kind of level out to any number. So we say this does not converge. It doesn't have a limit, so it doesn't converge. Learn about increasing and decreasing and that kind of stuff. But for now, just converge and diverge, look for the limit towards infinity.